Before we leave section 7.2 behind, we have a very important definition to learn, and also we need to go over how to find these. And those are the critical z values. Now, critical z values are going to show up in every lesson pretty much from chapter 9 onward. So we kind of need to know how to do this for later. So let's look at what they are. Now, z is because it's a z-score. So you're going to be finding a z-score, finding a vertical line on a normal curve. Right? And of course, the z-curve, automatically we know if we see the letter z, the mean is 0, the standard deviation is 1. That is just how z-curves work. Okay, if we look at the critical z value, it's a z-score with a little subscript behind it. So that little subscript will be a number. It'll be a number between 0 and 1. And it's not an A. I know it looks like it is, but that's just because of the font I'm using. It's actually alpha. It's a Greek letter. So if ever you're in Greece, it makes the A sound for Greek. Alpha. It looks a little bit like the fish symbol that people have like on the back of their cars, that kind of thing. So it's the z-score that has the area alpha to its right under the normal curve. So if you look over here in the right-hand picture, Z alpha is the vertical line that cuts off this shaded region. The shaded region has an area of alpha. So the gray part has an area of alpha. The line that cuts off that gray part is Z alpha. It's the critical Z value. Negative Z alpha is the same thing but on the left side. So positive Z alpha is on the right, negative Z alpha is on the left. So the area is still alpha, still that gray shaded area. The vertical line there is negative Z alpha. All right, so let's look at an example, and that'll probably help us. And I apologize, this particular semester that I'm making this video, there was a typo here. So just change out the question for Z sub 0.10. So see that little subscript? That subscript means that alpha is 0.10. So let me type that up. So alpha is 0.10, that's the area in the right tail, and that's because it was a positive z, right? So since it's a positive z, I'm looking for the area in the right tail. So I'm going to draw a picture that looks a lot like this picture up here. 1 second. There, I've labeled my area as alpha, which is 0.10. I've got my z, which is that vertical line, and just a little reminder that mu is 0, which is in the middle. So now I want to find that value, that z-score. Okay, so to find a z-score, let's bring up the decision matrix. So let's see here. I know an area. I was given the area of 0.10 right here. I want to find a z-score, right? Z sub alpha. So that means I'm going to use inverse norm, the left tail area, 0 and 1. So that will be how I find this. Inverse norm, left tail area, 0 and 1. So if I'm going to do that, I'm going to need the left tail area. So you'll notice the right area was 0.10. Well, actually, I have it up above, right? 0.10 was the area in the right tail. So the left tail area would be 1 minus that, which would be 0.90. So when I go to inverse norm, I'm going to put in 0.90 as my left tail area, and then 0 and 1. All right, so let me grab the calculator. Go to second distribution. Inverse norm is number 3. All right, so I'm going to put 0.9001. Now I have the most new operating system, which actually gives me an option here for this one. So, but most calculators still only have the left option. It doesn't even have a tail. It just says area mu sigma. So if it does, then you assume you're on the left side and you'll paste and it'll say the word left and you press enter. Now for you, if you don't have that tail option, it won't say the word left. It'll just have 0.9, 0, 1. For me, I actually have that extra step. So let me show you. I could do it a different way with my calculator. So with my calculator, I could say 0.10, but I just tell it that that's the area in the right because I have this new operating system on my calculator. So if I tell it 0.10 on the right, There we go. I get the same answer, 1.282. So if you write it this way, we're assuming always that you're doing the left tail area because that's what almost all 84 calculators still do. A few new calculators are starting to do that extra option that you saw on my screen. But it's not widely available yet. So for right now, either follow the same rules as before and just do 0.90, right? Or if you have a new calculator, you can do 0.10 and then just tell it right. But if you're going to do that, then write the word right over here or the word left, right? If you have the new kind of calculator. Otherwise, you can just leave it 0.90, 0, 1. Okay, now what about this one, letter B? Well, this is a negative z.04. That means that the area in the tail is 0.04, but it's on the left tail this time because it's a negative z. Okay, so now let's think about the picture for a second. When I go to get this picture from the computer program, I'm going to be shading on the left side, but I'm only going to shade 4%, which is going to be a smaller amount shaded than I have here for 0.10. So just keep that in mind. And I will make a computer do this so we'll know if I'm actually correct. All right, so you can see my intuition was correct. So the computer labeled that as about 4%. So if you're curious to know what about 4% looks like, that's what it looks like. So that's alpha, which is 0.04. It's not negative alpha. Alpha is always positive, so it's always between 0 and 1 because it's an area under the curve. And of course, probabilities cannot be, which is what alpha is, probabilities cannot be less than 0 or greater than 1. So I've labeled that. Now I already have the left tail area. So I already know to put into inverse norm 0.04. And I forgot to label this one up here, but just suffice to say this was z alpha, or I should say z alpha was equal to z 0.10. That's what we found up here. All right, so for the one we're looking at right now, let me put this at the very end here. That might make it more sense. So the one we're looking at right now, we want to do negative z alpha, negative z 0.04. Okay, well, negative z.04 is going to be inverse norm again because I know my area and I'm looking for my z-score. I know my left tail area in particular is 0.04. So I'm going to tell it inverse norm 0.04. And this will be my negative z alpha that I'm looking for. So it's negative z.04. So I have to go tell the calculator to do this because I don't know what the number is off the top of my head. So I'm going to grab my calculator. I'm going to tell it inverse norm. So second distribution, number 3. I'll say 0.04. 0 and 1 never changes for z's. Z's are always the same. If you have an option like I do, pick left. If you don't have an option, just assume it's automatically left, which is the way all the old calculators are. Go down to paste and press enter. And it pastes it into the home screen. Let me click enter again, and I'll get negative 1.751. So negative 1.751. There we have it. That's how to find critical values. And again, this will come back a lot in a later section. So just be warned, you'll be doing this a lot once chapter 9 and 10 and 11 hit. So it'll probably be on the test.